So this video is going to go through question 3 of sample paper D. So we'll just move it across, you can see there. And this question has got to do with CAD, got to do with developments and orthographic projection. So for 3A, it tells the image below shows a design for a juicer. The funnel is based on a truncated cone and the body contains a sloped surface with a curve. Name 2 CAD commands that can be used to create the design of the juicer. Write the commands in the space provided below and then join them to the appropriate part of the design. So the first CAD command we could say that was used was extrude. So extrude could be used, for example, to make the cylinder. So you could say is you drew the circle and then that was extruded then to form that cylindrical part. A second CAD command you could say would be revolve. So revolve could be used for the conical surface. So for example, you would have your outline of your cone that's inverted and you use the revolve tool then to make that 3D shape then. For part B, the image opposite shows the funnel of the juicer, so the top part here. The elevation plan and incomplete development of the funnel are also shown. Complete the surface development of the funnel. So basically what they've given you is the extreme generator BA and down to O where it's cut off, and that's given to us here. So we know from doing our CBAs and our projects, if we draw the development of a cone, we go from O, which is our apex, so it's inverted, and we rotate that around. That's going to be a true length. We know in plan a line parallel to the XY line is going to be a true length. So that point there would be O, that would be A, and that would be B, so that's going to be a true length, because we always involve true lengths when we're drawing true shapes. After that then, we need to be able to step out our distances from here all the way around here. The only way to measure that is by dividing our circle up into equal parts and then taking those as our individual measurements. So I can use my 30/60 set square here and divide this into 12 equal parts like that there. And I'm going to label it 1, 2, 3, that's already B, 4, 5, 6, 7, 8, 9, 10, 11. This distance on my compass from 1 to 2 is the exact same as 2 to 3, 3 to B, B to 4, etc. So from B, I'm going to continue on all the way until I get to B again. So from B, I get 4, 5, 6, 7, 8. So if you can see that, I'll just move this down a bit. 9, 10. I need to extend that a bit more. So I go back in here again. So I had B, 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, and then B is going to be out here as well. So I'm going from B all the way back around to B again. So you can see why I've labelled it to make sure I get it right. So 4, 5, 6, 7, 8, 9, 10, 11, 1, 2, 3, and back around to B. That joins back in there. And then I rotate A around as well, because remember it's cut off, it's not a full cone. So just one sec, I just changed the lead there. So I just forgot to unpause the video when I just drew the circle there. So that's going from O to A around. Then after that, all my generators join back to the top, and I draw my fold lines to show that it folds up to form my conical shape that I have left. So it's important you always draw in your fold lines. And that completes part B. So for part C then I'm just going to pause the video and put on the new page and then start that from there. So for part C then, it's all going through the orthographic projection. So we're still looking at the exact same juicer from parts A and B. It tells the image below shows the dimension drawing of the juicer. Draw 1 an elevation in the direction of arrow A. So arrow A is pointing to the right, therefore our elevation is going to go to the right hand side. A plan projected from the elevation, which will go below. And then part C, an end view in the direction of arrow B. That'll be going out to the left because the arrow is pointing towards the left. So the first thing, as always, I tell you to do, draw boxes to fit your views inside. So get your total widths, your total heights, your total depths, and draw boxes to fit them in. Just going to move this camera over so you can see the right hand side of the page. First thing I'm going to do is get my heights. So I can see there, I have 50 up to here, and I've then 2 sets of 20s to the top. So that gives me a total of 90. So what I'm going to do is go down maybe about 10-15 mil from the top, draw a line across there, and I'm going to come in maybe 15-20 mil from the right, and that's going to be the top right of my drawing. So I've already worked out it's 90 mil tall. My elevation is going to be that tall there. There's my baseline for my elevation, and when I look at my elevation, my total width is 70. So I now have a box to fit my elevation. So my elevation is going to go in there. I'm going to put a gap in between my elevation and my plan, maybe about 15-20 mil. And this time then when I'm looking down the plan, I can't see heights, I only deal with widths and depths. I already have the width of it, it's 70 mil wide. I just need the depth of it going from here to here. And for that there, it's inclined at 60 degrees, so I won't be able to get the total for my plan yet. So what I'll have to do is leave that box for now and start working out my end view. So that 60 degree line, I'm going to have to use that to figure out the depth of it. So I'm going to go 45 degrees here, and this is going to be the box to start my end view. So my end view is going to be going in here. For my end view looking in this way, I'm dealing with heights and depths. So I don't have the depth at the moment yet for that, but I'm still able to use the measurements I have to get my 60 degrees. So I already have my height, so I'm going to start with my end view then, just to get the box for it to be complete, so I can start drawing my plan view and my elevation as well. So my first height I'm given is my 50, and I'm told to go out 32 to that edge there and then go at 60 degrees. So if I go up 50 here, go out 32, go at 60 degrees from there, that's now giving me the full width. I can now use my 45 degree set square to get that there, and that can give me now a box for my plan to fit inside. Now I know my drawing isn't going to go off my sheet. I'm not going too far to the right, too far up, too far down. I have plenty of space. So I'm going to go back to my elevation and start off with that there. So what I see looking in this way, I'm going to see that slope surface first. I'm going to see this cylinder coming out and then the cone on top of it. And I'm going to have this cut surface or this slope surface as well that I'll worry about afterwards. I'll need to use other views first to get that. So I already have my 50 marked off here, that height, and that's just a rectangle outline there in my elevation. When I look in, I just see a rectangle. The height of the cylinder part is 20 and it's a radius of 8. So I get the halfway point, 35. Radius 8 means I go 8 each side. And then 20 there. I'll just keep that center line because I'll need it for the plan. And then for the cone, it's a radius of 25. So that means for my center, I'll be going out 25 each side there and there. And that joins back like that and that. And for now, that's all I can complete for my elevation. With those measurements, I can now take them down to my plan and draw my plan view. So in the plan, I'm going to see a circle here for my cone. I'm going to see a circle here for my cylinder. I'm going to have a rectangular outline that's going to be partially covered because of the circle or the cone sticking out, and I'm going to have that rectangular surface at the front there. So first thing I'm going to do is draw out the rectangular outline here and the rectangle for the front. So I'm told it's 32 mil out to that front part there. I'm going to leave it light for now because I don't know what part is going to be heavy. And then I go halfway back on that for the center of my circle for the cylinder and the circle for the cone. So I go 16 mil there for my center, and I'm going to draw now as my circles for both of these. So one's a radius 25 and one is a radius 8. I already have my radius 25 up here. I can take that, draw it in heavy. Oops. Like that there, and then take my radius 8 as well. And draw that in there as well. And just rub out that bit. Now I can draw in the outline of my rectangle here, and I can see that because the cylinder, or sorry, the cone is blocking it, it's going to be hidden detail there. And for the back, it's going to be hidden detail there. That rectangle is that one there, and this rectangle is going to be this one here as well. For this part here, this slope at the front, it's based on, you can see, half a cylinder that's extruded down and just relieves that mark then on the surface. That's a radius of 22, and I'm told it's a further 5 mil out. So if I go another 5 mil out here, like that, with that as my center point, I can take a radius of 22 and I'm just drawing a light semicircle here for now. Well, it's going to appear as a semicircle in plan anyway, because it's based off a cylinder. In the other views you'll see a curve. So what I can do is I can draw that like that there, heavy across there and there, and once again, because it's blocked by this little portion of the cone, it's going to be light then. So what I'm going to have to do is divide these points up and take them up and across to get my elevation view of it. So for my end view, I have part of it already completed. Looking in this way, I have that outline already here. I can draw that in using the measurements I already had and the angle that I was given as 60 degrees down here. For the end view then, I can take my heights across from my elevation as well, and then I can take my cylinder across here, take it up 45 straight up there, and that now gives me the cylinder there, and then the outline of the cone can be taken up as well then after that. And join back down there as well. That completes our end view. So to get this curve here on the front, I need to divide up my circle in plan, my semicircle. So as always, when we're dividing a circle up, we divide into 30/60s and we label our parts, so each of our divisions. So 0, 1, 2, 3, 4, 5, 6. We're told that already the 5mm that I came out here for that bit, it comes out 5mm in my end view as well. And that point there is the top here. So if I was to take that across, over and up, I would get that point as well. If I follow it up, over and across, that's 0 and 6 there. What I want to do now is take all these points over, up and across to find them in my elevation. So you can see 1 and 5 are on the same line there. They go up like this. And I have 1 and 5 there. 2 and 4 are on the same line in plan there. They go up, over and across as well, giving me 2 and 4 there. And 3 on the very bottom, it's just going to go up and in slightly there. So where they are in my end view, I can now take them across to my elevation. So if I take 3 across and 3 up, that gives me 3. I take 4 and 2 across. Take 4 up, there's 4 there. Take 2 up, there's 2 there. The exact same with 5 and 1. Take 5 and 1 across. That's 1. That's 5. And then 0 and 6, my widest points. 0 and 6 go up like that there. They go across there. Give me 0 and 6. And then all it's a matter of doing is drawing a nice neat freehand curve. Like that. Now just to show with colour how I got, say, one of those points. If I use this blue colour here, this bluey purpley one, let's say I take point 2 here after I divide it up. 2 goes over like that, my end view, or sorry, to the edge of my plan, goes up at 45 degrees, straight up to hit the slope surface here in my plan, sorry, my end view. It then goes across and it stops where point 2 goes up from the plan into the elevation. And that then completes the question 3 there. So that's question 3 ABC. So a good bit of work in this one here.